Okay, so we will see now dual simplex method. We have seen what duality is. Now we'll see dual simplex method. Okay, so it's quite similar as simplex method. Dual simplex method mein what we do here, like we have seen in simplex method, it is maximization thing, but in dual simplex it is, we can see here, it is minimization. In dual simplex it is minimization. This thing is same. Convert all constraints in less than or equal to type. Here as well we convert all the constraints into less than or equals to type. If it is given greater than or equals to, if it is given greater than or equal to type, then we multiply throughout by -1 and change the inequality sign. And if equality is there, then also we somehow change it, and just we want here less than or equals to. Okay, we just need to remember one thing: minimization type. It should be, to apply dual simplex, it should be minimization type. All the constraints should be of the form less than or equal to type. Okay, then if inequalities ko we will convert into equalities by adding slack variables. Okay, we will add some slack variables and we will convert the inequalities into equalities. Now we will put all this information in a table like we were doing in simplex method. We will form a dual simplex table here like this. If this is the given equation, we are assuming again three variables, three decision variables we are assuming, and three constraints we are assuming, B1, B2, B3, right? Three constraints we are assuming. So if three constraints are there, then three slack variables will be there. So in total we will have 6 variables here and 3 constraints, right? So we will make a table similar as simplex, similar as what we were doing in simplex. Okay, so we will again do iteration, then basic variables, coefficients of x1, x2, x3, s1, s2, s3, and RHS. Okay, so what is the change here? If we will see the next 5th point. So what is the 5th point? If all the coefficients in the row of Z are negative and all the right hand side constants, that is B's, are positive, then basic feasible solution is obtained. Okay, so here we can see, if all these are negative and all these are positive, then we are done, we are through. Whatever we have, it is our basic feasible solution. But if any one of these is not positive, if any one of these is not positive, then we need to proceed towards 6th step. So what 6th step is saying? Look at the last right hand side column. Select the row which contains the smallest number in the column of B's. And notice this thing, it should be the negative number. So we will choose the smallest negative number. So this will be the, we will again denote it by an arrowhead, and then we will go forward. And one thing here, so we are choosing here first outgoing variable. Okay, so whatever, let's assume in B1, B2, B3, B2 is the most negative. Okay, it is the smallest one. So what we will do here, we will choose this. We just represented it by this arrowhead, and we are choosing this column, sorry, this row. We are choosing this row. This will be our pivot row. So we are choosing the outgoing variable first. So S2 will be the outgoing variable. Okay, S2 will be the outgoing variable. So next what we will do, then the 7th step says we will take the ratios of coefficients of this Z with the pivot row. Okay, so we will find out -C1 by A21, -C2 by A22, and -C3 by A23. So we got these 3, and now we will choose here the smallest ratio. So the smallest ratio, let's assume C1 by A21 is the smallest ratio. Then what we are doing, we are denoting this as our pivot column, and this is how we are choosing the incoming variable. So x1 is the incoming variable. So what we know now, s2 is outgoing variable, and x1 is incoming variable. Then rest we will do the same as we did in simplex method. We will convert this 8 to 1. This is the common element, right? Common element in pivot row and pivot column. So 8 to 1 ko we will convert it to 1. And then what we will do next? इसको 1 से कन्वर्ट करने के लिए what we will do, we will use some elementary row operations like we were doing in matrices, right? Matrices में हमने किया हुआ है सारा elementary row operations, तो we will do the same thing here. So we will convert this a to 1 to 1. Okay, we will make it unity. a to 1 को unity बनाएंगे and बाकी जो भी इस column में ऊपर नीचे इसके elements है we will make them 0. And rest everything will get applied to other elements also. Okay, so whatever row operations we will do with each and every element here. Okay, so this is and then we will write down another table like we were doing in simplex, and we will simplified terms we will have, and then we will see. Of course, everything is whatever we are doing with these rows here is happening with these BIs also, right? We are getting some solution here, and B1, B2, B3, they are also getting changed in the process, right? So we will get some new B1, B2, in place of B1, B2, B3, we will get some new numbers here. So we will again check if there is any negative number. If there is any negative number, then what we'll do, we'll repeat the process. If there is no negative number, we will stop there because we will have the solution. Okay, we will have the solution. So whatever the values will be here, B1, B2, B3, and whatever we will have here, x1, x2, whatever variables we will have, these will give values for B1, B2, B3, and this place, whatever number we will get after solving will be our Z minimum. Okay, so this is how we can solve this further. And one more thing, अगर यहाँ पे जो C1, C2, C3 है, these all will become, यहाँ z का सारा ऑब्जेक्टिव फंक्शन का सारा कोएफिशिएंट will become अगर पॉजिटिव, दैट मीन्स अगर यहाँ पे सब पॉजिटिव है तो मेथड फेल्स. ओके, सो मेथड फेल्स. So let's see what else we have. So we will continue the process till all the b's are positive. Okay, so we will have, this is how we will have the required solution. So this is some comparisons between regular simplex method and dual simplex method. You can read it and then you will get to know it's not there are not much differences. A few differences are there what we have discussed while the process also, like instead of maximization it is minimization type, right? And then we are first choosing the outgoing, then we are choosing the incoming variable, and likewise some few differences are there. So you can read it out and then you will get to know what they are. Okay, so let's see a problem so that we will get it better, the dual simplex method. So यहाँ पे what is the question? Use the dual simplex method to solve the following LPP. Minimize z is equals to 6x1 plus 3x2 plus 4x3 subject to x1 plus 6x2 plus x3 is equals to 10. Okay, and 2x1 plus 3x2 plus x3 is equals to 15. So we can see here both are equalities. But what we know, we don't want equalities here. What we want here, we want inequalities here. That too less than or equals to type. But if it is equals to, how I can get less than or equals to? What we will have here, see, we can see here x1 plus 6x2 plus x3 is equals to 10. So we can write it as x1 plus 6x2 plus x3 smaller equal 10. And see, this is important, and when both the conditions are true, then only we can say it is equals to 10, right? So we will have x1 plus 6x2 plus x3 smaller equal 10 and x1 plus 6x2 plus x3 greater equal 10. So both the things we will have, then only we will have equals to. But the first condition is fine. We want less than or equals to. Second one is greater than or equals to. We don't want greater than or equals to. We want less than or equals to. So what we know, how can we convert it to less than or equals to? What we can do here, we can multiply throughout by minus 1, right? So we will multiply throughout by minus 1. What we will get then? Minus x1 minus 6x2 minus x3 smaller equal minus 10. when we are multiplying throughout by minus, we are changing the sign, right? We are changing the sign greater than equals to less than or equals to. So we got this. The second equation is also similar. 2x1 plus 3x2 plus x3 is equals to 15. Again, we need inequality sign here, that to less than or equals to. So what we can do here, we can write it as 2x1 plus 3x2 plus x3 smaller equal 15, and 2x1 plus 3x2 plus x3 greater equal 15, right? Greater equal 15 ko we will convert into smaller equal minus 15 by multiplying throughout by minus 1, right? So now we can easily see here, we have 4 constraints, right? How many constraints we have here? 4 constraints. And how many variables are there? 3 variables. Okay, so 3 variables we have, 4 constraints we have. x1, x2, x3 are greater equal to 0. We are good to go. We can solve this inequality, solve this linear programming problem using dual simplex method now. So the standard form, we will convert it to the standard form now. So standard form, what we have? Minimize z is equals to 6x1 plus 3x2 plus 4x3. We are adding the slack variables here, right? Minimization, what is the standard form? We are adding the slack variables. We are converting these inequalities to equalities now by adding the slack variables. So for first constraint, we will have s1. For second constraint s2, for third constraint s3, and fourth constraint it will be s4, right? So बाकी सबके साथ we will multiply 0. So it is like s1 plus 0 s2 plus 0 s3 plus 0 s4, like as we did in simplex. So we are doing the same thing here. Okay, so now we will form this table. This is our simplex table. Iteration number, 0th iteration. So basic variable, coefficients of x1, x2, x3, s1, s2, s3, s4. 4 slack variables. Why 4 slack variables? Because 4 constraints are there, right? So 4 constraints are there. That's why 4 slack variables we will add here. So objective ko we can just simplify. Objective ka coefficients kya rahega hamara? We will have we can take this, we can write this as z minus 6x1 minus 3x2 minus 4x3 plus 0s1 plus 0s2 plus 0s3 plus 0s4 is equals to 0. So we can write the coefficients of x1, x2, x3, s1, s2, s3, s4 here. Minus 6, minus 3, minus 4, 0, 0, 0, 0. RHS mein kya hai? It is 0 only, right? Now the other basic variables are s1, s2, s3, s4. Correct? And we have this table, this body matrix we will write down here. From where this body matrix is coming? It is coefficient matrix of these 4 constraints. We have these 4 equations, the 4 constraints. The 4 equations we are getting from 4 constraints, right? So we will write down the body matrix here. पहला तो जो equations है उनका body matrix आएगा. Then there will be this identity matrix of 4 cross 4 order. Okay? RHS हमने यहाँ पे लिख दिया. BIs का value 10, minus 10, 15, minus 15. Now then what we need to check here? So ऊपर it is fine, everything is negative, we are good to go. Now then we need to check the BIs. Any of the BIs is negative? Yes, we have 2 BIs negative. B2 and B4 are negative. And which one is the most negative? Which one is the smallest number here? Minus 15. Minus 15 is the smallest number. So we will choose this row now. Minus 15 वाला row हम choose करेंगे. So that means our S4 will be outgoing variable. Okay, S4 will be outgoing variable. Now next what we supposed to do? We supposed to take the ratios. जो objective function के coefficients हैं उनका जो ये अपना minus 15 के साथ जो हमारा pivot row आया है उन दोनों rows का we will take ratio. So we will take ratio. So what we will have? Minus 6 by minus 2 will be 3. Minus 3 by minus 3 will be 1. Minus 4 by minus 1 will be 4. So now we can see easily here which one is the smallest ratio. So 1 is the smallest number here. So we will choose this column as our pivot column. So now we know S4 is the outgoing variable and which one is the incoming variable? X2 is the incoming variable. So S4 leaves, X2 enters. Now next what we supposed to do? We supposed to convert this minus 3 as 1. Right, we supposed to convert this minus 3 and verse 1 and above everything will be 0 and rest everything we will make the difference, we will make the changes using the elementary row operation. So we will just see using matrix for one iteration. Okay, so we just wrote down this in form of matrix. It is you can see we have written all the numbers here, including this RHS column, in this matrix form. Okay, so then what we need to do here, -3 को हमने 1 बनाना है. तो what we supposed to do to make -3 1? This is our 1 2 3 4 5 fifth row. So fifth row को we will divide by -3 to make we will divide by -3 to make it 1. So we are doing this elementary row operation. R5 को we are changing by R5 by -3. So this will, the last row will become 2 by 3 -2 it is, right? So it will become 2 by 3, then 1 1 by 3 0 0 0 -1 by 3 and 5, right? This thing is done. Now we need to make everything above it 0. So for that the required operations are, हमें R4 को 3 times R5 से subtract करना पड़ेगा. So R4 will be R4 minus 3 R5. R3 will be, this is -6. So what we supposed to do here, 6 times R5 के साथ इसे add करना पड़ेगा. So R3 will be R3 plus 6 times R5. Similarly R2 को के यहाँ पे 0 के लिए what we supposed to do, R2 minus 6 times R5 and R1 plus 3 times R5. So all row operations we have written here. We are doing all the row operation in with every element of the rows, and we are getting this resultant matrix. Then in our next table, simplex table, we are writing all these elements here, this matrix. Okay, we are writing it in form of the simplex table again. So we have this now. So this thing is fine. Now what we need to do, we need to again check, is there any negative BI? Yes, there is one, -20. -20 is the negative, only negative number, right? So -20 is the negative. That means this row along with -20 will be our pivot row. And which element? S1. S1 is the variable which is outgoing. Okay, S1 is the outgoing variable. Now next what we need to do, we need to take ratios of this pivot row, elements of this pivot row with the coefficients of z, right? Coefficients of x1, x2, x3 in the objective function, right? So we can take the ratios. So 4 by 3, 0 by 0, we cannot define this thing, so we will leave it as it is. So 4 by 3 we have, 3 by 1 we have. So 4 by 3 and 3 में से which one is smaller? It's quite easy to see, 4 by 3 is the smaller one. So that means this first column will be our pivot column, right? So that means which is incoming variable? X1 is the incoming variable. So here S1 is leaving and X1 is entering, right? S1 is leaving and X1 is entering. So this thing is fine. Now next we know what we're supposed to do. We're supposed to make this -3 1, right? We're supposed to make this -3 1, and rest everything in this column should be 0. Accordingly, same changes we will make with every element here. So I'm not writing again the matrix, I'm directly doing it here. We can do this directly, we can do it here, or if you are not comfortable doing it here, you can just separate the matrix, do the operations, and then the resultant matrix write down here. Okay, so for this step I have directly done these things here only. So what we are getting, we made this one, these all terms 0. You can see which row operations we have used. It's easy, it is the same thing we have done plenty of times in matrices, right? So we are doing the row operations and simplifying it, and we are getting this matrix, right? So now we can see every BI is now greater than 0. There is no negative BI, right? There is no negative BI. That means now we have our solution. Okay, so what will be solution? This is x1, यहाँ पे वैल्यू क्या दिया है? 20 by 3. x2 के साथ क्या वैल्यू दिया है? 5 by 9. So x1 का वैल्यू we got 20 by 3, x2 का वैल्यू we got 5 by 9, and since x3 did not enter this, so that's why x3 will be 0. And here यहाँ पे what we are getting, this is our z का वैल्यू, z minimum, 125 by 3 is our Z minimum, right? So this is the solution for this simplex method. Similarly, we can do all other problems. Thank you.